So this video is the review for 9.6, so you're going to need the green foldable that I have on the screen. So we're going to be finishing up that foldable by solving some problems involving angles for our right triangles. So I'm actually going to be using a white copy just so you can see it a little bit better on the screen. So in our foldable, we're going to be starting with sine. So as a reminder, when we're dealing with sine, that's the opposite over the hypotenuse. Opposite over hypotenuse. So we're going to start here with questions number 3 and 4. So starting here with number 3, you'll notice we have our angle that we're trying to find, and then we have the side opposite as well as the hypotenuse. So we're going to write out our equation. So we're using sine of x equals the opposite, which is 9, over the hypotenuse, which is 14. So in order to solve for x here, if you remember, we're going to essentially be dividing by sine on both sides, so we get x by itself. So we get x equals, we can't leave sine on the bottom by itself, so we're going to move it back up to the top. In order to do that, we're going to use the -1 exponent. So this is going to be sine to the -1 of our fraction, which is 9 over 14. So then we're going to punch that into our calculator. So on our calculator, we're going to hit, for this one, since sine to the -1 is in green, we're going to use the second button and then hit sine. So we have sine to the -1. And then in parentheses, we're going to put our fraction, which is 9 divided by 14. Close our parentheses and hit enter. We're going to be rounding all of these to the nearest hundredth. So we're going to go 2 decimal places. So for this one, we have 40.01 degrees. So x is approximately 40.01 degrees. Okay. All right, so for the next one here, number 4, again, we have the leg opposite as well as the hypotenuse. So looking at the angle x, so we're going to say sine of x equals opposite, which is 31, over hypotenuse, which is 38. So in order to solve for x, we're dividing by sine on both sides. So we get x equals, we want sine to the -1, so we move it up to the top. And then in our parentheses, we want our fraction, which is 31 over 38. It is important that you actually put the fraction in parentheses. Otherwise, your calculator is going to take sine to the -1 of 31 and then divide that answer by 38. And we don't want it to do that. We want it to do 31 divided by 38. So on our calculator, second, sine. Inside my parentheses, I want 31 divided by 38. Close my parentheses and hit enter. So we get x is approximately 54.67 degrees. So x is approximately 54.67 degrees. Okay, those are our 2 sine examples. Now we're going to go on to cosine. Feel free to pause this video if you need to. So for cosine, just as a reminder, cosine is adjacent over hypotenuse. So looking at examples 9 and 10, we're going to be working with cosine. So we've got our angle x. So from x, we have the adjacent leg, and we have the hypotenuse. So our equation is going to be cosine of x equals the adjacent, which is 44, over the hypotenuse, which is 52. To solve for x, we're going to divide by cosine on both sides. So we end up with x equals cosine to the -1, remember we're moving that up to the top, times our fraction here, which is 44 over 52. Okay, so then on our calculator, we're just going to type that in here. So second, cosine this time. So we have cosine to the -1. Inside my parentheses, I want 44 divided by 52. Hit enter, and to the nearest hundredth, we get 32.20 degrees. So x is approximately 32.20 degrees. Okay, for number 10, again, we're looking at our angle x. We have the adjacent leg, which is 19. We have the hypotenuse, which is 24. So our equation would be cosine x equals adjacent, which is 19, over hypotenuse, which is 24. To solve, we're going to divide by cosine on both sides. So then we're left with x equals cosine to the negative 1 of our fraction, which is 19 over 24. So then on our calculator, we're going to type in second cosine to give us that cosine to the negative 1. And then in our parentheses, we want 19 divided by 24. And so that gives us 37.66 degrees. So x is approximately 37.66 degrees. Okay, so those are our two cosine examples. The next page is tangent. So remember, tangent is opposite over adjacent. So looking at examples 15 and 16, starting out by looking at our angle, we have our opposite, which is 21, our adjacent is 25. So our equation would be tangent of x equals opposite, which is 21, over adjacent we said was 25. And then we're solving for x, so divide by tangent on both sides. So we end up with x equals tangent to the negative 1, we're moving that up to the top, and then 21 over 25. Typing that into our calculator. So we get second tan this time, so tangent to the negative 1. In our parentheses, we want 21 divided by 25, and hit enter. So to the nearest hundredth, we get 40.03 degrees. So x is approximately 40.03 degrees. All right, number 16. Again, we start by looking at our angle. We have our opposite side and our adjacent side. Remember, those are our legs. So we're going to go tangent of x equals opposite is 6 over adjacent, which is 10. So then to solve for x, we're going to divide by tangent. So we get x equals tangent to the negative 1 of 6 over 10. So typing that into our calculator, second tangent, and then we want 6 divided by 10. Hit enter, and to the nearest hundredth, we get 30.96 degrees. So x is approximately 30.96 degrees. Okay, so those are the three trig functions that we've been talking about, sine, cosine, and tangent. So the next four questions that we're going to work on are mixed review. So this time you have to figure out which trig function we're going to use for each problem. So in order to do that, we always have three pieces. So we need to decide with those three pieces, are we going to use sine, cosine, or tangent? So for number 19, we've got our angle. That's our first piece. Looking at this angle, we have the leg adjacent and the hypotenuse. So that means we're going to use cosine. So cosine of x equals adjacent, which is 31, over hypotenuse, which is 47. So to solve for x, divide by cosine, and we get x equals cosine to the negative 1 of 31 over 47. Typing that into our calculator, so we've got cosine to the -1 of 31 divided by 47. To the nearest hundredth, we have 48.73 degrees. So x is approximately 48.73 degrees. Moving on to number 20. We always start with our angle, and we're looking at the sides in relation to that angle. So we have the opposite leg and the hypotenuse. So that means we're going to use sine of x, because that is opposite over hypotenuse. So 24 over 29. To solve for x, we're going to divide by sine. We get x equals sine to the -1 of our fraction, which is 24 over 29. So on our calculator, we're going to type in second sine 24 divided by 29, and we get 55.85 degrees. So x is approximately 55.85 degrees. Okay, moving on to number 21. This time, again, we're starting out by looking at our angle. So from my angle, I have the opposite leg, which is 15, and the adjacent leg, which is 22. So that means we're going to use tangent of x, which is opposite 15 over adjacent 22. To solve for x, we're going to divide by tangent. So we get x equals tangent to the -1 of our fraction, which is 15 over 22. So on our calculator, we're typing in tangent to the -1 of 15 over 22, and we get 34.29 degrees. Remember your rounding rules, that 6 tells me I'm going to go up to 29. So x is approximately 34.29 degrees. The last one on here, looking at x, we've got the adjacent leg and the opposite leg again, no hypotenuse. So we're going to use tangent again. Tangent of x equals opposite, which is 9, over adjacent, which is 8. So to solve for x, divide by tangent. We get x equals tangent to the -1 of our fraction, which is 9 over 8. Typing that into our calculator, we're going to go second tangent. So we get tangent to the -1 of 9 divided by 8 and hit enter, and we get 48.37 degrees. So x is approximately 48.37 degrees. All right, so that's all for our mixed practice. So then the last piece that we have is a couple of word problems. So if you want to go ahead and turn the page, we're going to start with our angle of elevation problem, so number 29. So this one says Caitlin's mom is standing at the bottom of a water slide waiting for Caitlin to slide down. If the top of the slide is 40 feet from the ground and the slide is 48 feet long, what is the angle of elevation from Caitlin's mom to Caitlin? So we're going to start with a picture. So we've got Caitlin is up at the top of the slide, mom is down at the bottom. We know that the slide is 40 feet tall, so we're going to put 40 on the left. And then it says that the slide itself is 48 feet long, so that's our hypotenuse. And they want to know the angle of elevation from Caitlin's mom to Caitlin. So that's this angle down here because we're looking up from mom to Caitlin. So we're going to put an X there for our angle. So looking at the information that we have an opposite side, an opposite leg, and we have a hypotenuse. So that means we're going to use sine of x equals opposite, which is 40, over hypotenuse, which is 48. So in order to solve for x, divide by sine. We end up with x equals sine to the negative 1 of 40 over 48. So typing that into our calculator, second sine, so we have sine to the negative 1, and then 40 divided by 48. We get 56.44 degrees. So x is approximately 56.44 degrees. Question number 30. Jaden, who is looking up at the top of a 56-foot rock climbing wall. If Jaden is standing 15 feet from the base of the wall, what is the angle of elevation from Jaden to the top of the wall? So again, I'm going to start with a picture. Jaden's down at the bottom. We've got this wall. We know that the wall, it says, is 56 feet tall, so we're going to put that on the left. And then it says that Jaden is 15 feet from the wall, so 15 goes on the bottom. We want to know the angle of elevation from Jaden to the top of the wall, so Jaden's looking up, so that's going to be our x. So the pieces of information we have this time are the opposite and the adjacent. So we're going to use tangent. So tangent of x equals opposite, which is 56, over adjacent, which is 15. To solve for x, we're going to divide by tangent, and we get x equals tangent to the negative 1 of 56 over 15. When we plug that into our calculator, scoot this over a little bit, second tangent, so we have tangent to the negative 1 of 56 divided by 15, and we get 75.00 degrees. So x is approximately 75.00 degrees. Since we're going to the nearest hundred, we do want to have those zeros in there because there was something after it. Alright, so those are the two angle of elevation problems that we had. The next two are angles of depression. So we're going to look at numbers 33 and 34. So number 33, while on a hot air balloon ride over Washington, D.C., Xavier spots the White House below. If the horizontal distance from the White House to the hot air balloon is 1,478 feet and the hot air balloon is 2,109 feet from the ground, what is the angle of depression from Xavier to the White House? Well, let's draw a picture here. Okay, so we have Xavier is in the balloon, and then we have the White House is down at the bottom. We know that the balloon, the hot air balloon is, sorry, I was just reading here again, the horizontal distance from the White House to the hot air balloon, so that's this piece down here on the bottom, that's 1,478 feet. And then the hot air balloon itself is 2,109 feet from the ground, so that's going to go on the left. So 2,109 feet goes on the left. And we want to know the angle of depression from Xavier to the White House. Now remember when we talked about angle of depression before? We said that's the horizontal line of sight down to the object. So that's this angle here. We'll call that x. Now the other thing that we talked about is if we have two parallel lines, okay, so there are two horizontal lines cut by a transversal, then we know alternate interior angles are congruent. So that angle of depression is the same as our angle of elevation would be from the White House up to the balloon. So we're actually going to find this one since that's in our triangle that we drew. So we have an opposite side and an adjacent side, no hypotenuse. So that means we're going to be using tangent. So this is tangent of x equals opposite, which is 2109, over adjacent, which is 1478. And we're going to divide both sides by tangent to solve for x. So we get x equals tangent to the negative 1 of 2109 divided by 1478. So on my calculator, I'm typing in second tangent, so I get tangent to the negative 1, 2109 divided by 1478, close my parentheses, and I get 54.98 degrees, because we're going to the nearest hundredth. So x is approximately 54.98 degrees. Last problem. Scoop my paper over here. So the last problem we have here in our application section, Michael is standing on the top of the bleachers watching the football team play. He spots the team mascot on the field. If the bleachers are 40 feet tall and the horizontal distance from Michael to the mascot is 68 feet, what is the angle of depression from Michael to the mascot? So again, starting out with our picture. So we've got Michael is up here on the top. And we've got our mascot is down here at the bottom. Let's call that Y. We know that the bleachers, it says, are 40 feet tall, so that goes on the left. We know that Michael says 68 feet. The horizontal distance is 68 feet from the mascot, so that goes on the bottom. And we want to know the angle of depression from Michael to the mascot. So drawing that line of sight, so the angle is x, and we know that this angle of depression is the same as the angle of elevation from our mascot up to Michael. So we're going to look from our angle of elevation actually to see our two pieces. We've got an opposite and an adjacent, so we're going to use tangent of x equals opposite, which is 40, over adjacent, which is 68. To solve for x, we're going to divide by tangent. So we get x equals tangent to the negative 1 of 40 over 68. So typing that into our calculator, we're going to go second tangent, and then we want 40 divided by 68, and we get 30.47 degrees. So x is approximately 30.47 degrees. So that is the last problem I have in the review. Your green flipbook should be complete now. If you have any questions, feel free to ask them in class or email me. Have a great day and good luck on your scavenger hunt. Bye.